Hello students, today we will learn some basic but very important concepts of definite integration, and I am assuming that you know about the indefinite integration. Okay, so see why I am saying this. The first point is we know that integration of f of x dx is equals to some function g of x plus c, right, where c is some constant of integration. All right. Now, when we talk about the definite integration, what does it mean? That we just put in the limits over this integration sign. That is x equals to a to x equals to b f of x dx. So the answer is g of x plus c, right? But now there is a change that we just put in the limits here also, x equals to a to x equals to b. So the rule is to put the limit that first of all you will put the upper limit in the function, so g of b plus c, then you will put in the second lower limit and then do the subtraction, so which is g of a plus c, right? So when you solve it, you will get g of b minus g of a. So in the whole process, you can see that you just get rid of this constant of integration, right? Okay. Now the third point is we do the integration, but what is the restrictions on this function f of x? So see, the restrictions is that f of x should be continuous. F of x should be continuous in the interval, continuous in the interval a to b. Okay. If it is not continuous, then we can't do the integration. I'll give you some example later on. Okay, so there are 2 points. Now what is the geometrical meaning of integration of f of x dx when you talk about x equals to a to x equals to b? See, let's suppose I'm taking this graph, and this graph is looking like this. All right, and let's suppose this point is x equals to a line, this is x equals to b, and I have to find the integration of this curve f of x from x equals to a to b. This curve is y equals to f of x. Okay, so basically integration represents the algebraic sums of area bounded by y equals to fx, x equals to a, x equals to b, and this x-axis. Okay, let me make it clear to you. See, let's suppose the area of let's suppose this point is c1, this point is c2. Okay, and I give you the information that the area of this point a to c1 is 3 units, from c1 to c2 the area is 6 units, and from c2 to b the area is 15 units. All right. Now see, if I say how will you find the area from a to c2 f of x dx? Okay, what does it mean? That you are going from this point a to c2, you are going in this direction, you are going from left to right, right? So there is a convention in definite integration that whenever we go from left to right, then we will consider the area above the x-axis as positive and below the x-axis as negative. All right, so when I say from a to c2, that means we have to consider the two areas, one is this 3 and one is this 6. Can you see that? So what should I write here? The area which represents 3 is plus 3 because it is above x-axis, then minus 6 because it is below x-axis, or you can say I should write like this, plus minus 6, because this f of x integration a to b f of x, it is the algebraic sum. Algebraic sum, what do you mean by algebraic sum? That means we have to consider the sign also, we have to consider the sign. Okay, so the answer is minus 3, right? Okay, what about if I say I have to go from b to c1 f of x dx? Okay, now in this case you are going from this point b to this point c1, right? Like you are going in this direction. So This direction is from right to left, and I already told you, whenever you go from right to left, then there is a change in the sign. That means the area above the x-axis will be considered now negative, and the area below the x-axis will be considered as positive. So what should I write now? In order to go from B to C1, I have to consider the two areas. Can you see that? The area from B to C2 plus area from C2 to C1, right? So what is the area from B to C2? It is 15 given to you, but now we are going from right to left, so I'll just put in minus sign in front of it due to convention, then plus. Now what about the area from C2 to C1? It is 6, but it is below x-axis, so that means we have to choose the plus 6 sign, right? So what is the answer now? So minus 15 plus 6, which is minus 9. I hope you get some idea how will you uh, go with the sign convention. Okay, let's just take one more example of from this graph. So let's suppose if I have to find the integration I equals to a to b. Okay, now I'm just taking the whole interval a to b. So I have to consider the whole graph. Now see, this whole a to b means we are going from a to B, that means from left to right. So that means the areas which are above x-axis should be considered positive, and the areas below x-axis should be considered as negative. Okay, so let's just moving from this point A to this point B like this. Okay, so we have first of all plus 3, right? Then plus, we have minus 6, then plus, we have minus 15. Not minus 15, it should be plus 15. Why? Because we are above x-axis, right? So I should write here plus 15. Okay, so what do you get? 3 minus 6 plus 15, so which is 12, right? So in that way you can solve the integration from a to b f of x dx. See, there is another chapter which is area under the curve. Area under the curve. In that chapter, uh, we don't count the algebraic sum, like we don't consider the sign there, since area is a positive quantity, right? So that is a different thing we'll learn in the next chapter. But for this notation, what does this notation means? It always a algebraic sum. So that's the basic concept which will be used everywhere in this definite integration chapter. Okay, now there are some notes here. See, if you see the note number one can break given definite integral as many number of times. What does it means? In the previous example, we took a to b f of x dx, right? So, see, you can just write it down as a to c1 dx, I mean f of x dx. Then you can just split it again from, you can start from c1 to c2 f of x dx, and then you can start from c2 to c3 f of x dx, and then this cycle will goes on till cn to b. That means this is the first point and this is the second point. But you have to keep in mind that wherever you finish, like a to c1, then the second integral should start from c1, not some another number. Okay, we don't have to break the cycle. So it should be like this, it's going here, then it's this is c2, it should be starting from c2. All right. Okay, so in that way we can use this property. Okay, now the next note is one should break given definite integral where it is not defined or the definition of the function changes. Okay, what does it mean? This is very important property to remember. See, I'll just draw the two graphs in front of you to make you understand. So this one and this one. Okay, let's say this point is x equals to a, and this point is x equals to b, and your graph starts from something like this and like this. Okay, see, this point is C point. Now you can see there is a discontinuity at the point C. Can you see that there is a discontinuity at the point C? Let me just write it down. Discontinuity at x equals to C. Now, can we do the integration of this function? See, this is again y equals to f of x some function. Okay. Now, I told you that f of x should be continuous in part 1. Yes or no? Here. I told you that f of x should be continuous, right? So, but here the function is not continuous. So, what we have to do here is we have to see the first part of this integration. Can you see this is the first part of the integration and this is the second part of the curve, you can say. So if I just consider the point behind C and in front of C, like before C and after C, right? So before C, can I say this point is C minus, and after C, can I say this point is C plus? All right, because see, if I have to say a to b f of x dx, so how will I define this function is, I'll say that it should be going from A to C minus, not C minus. Alright, then f of x dx, then plus. Now the function should be from C plus to B f of x dx. Why I choose this thing? Because in the first part, see, in the integration sign the function should always be continuous within the limits, right? So from a to c minus I can see my function is continuous, right? There is no break in the first part. Similarly, in the second part starts from c plus and ends at b, so there is no continuity, like no discontinuity at this function in this interval, right? So that's why we have to write like this. So this is the first case where the your definite integral is not defined, right? Now let's choose the second case where the definition of the function changes. All right, what does it means? So let's say the graph is now looking like something. Here it is x equals to a, this is x equals to b again, and then we have again a point x equals to c, but now the graph is something like this. Okay, see, there is no discontinuity at point x equals to c. Yes or no? Okay, so what we write here is integration from a to b f of x dx is defined as a to c f of x dx plus c to b f of x dx. Can you see that at the point x equals to c, the definition of the function changes. Before the slope is increasing, before c the slope is increasing, and after c the slope is decreasing. All right, I'll just give you an example of this, but you can see there is a change in the function. All right, so whenever there is a change in the function, we will define the integration a to b f of x like this. Okay, let's just take an example of these two concepts. So the example is, let's suppose I have to integrate minus 1 to 1 differentiation of cot inverse of 1 over x. Okay, see, what does it means is, whenever you write d of, let's suppose, x square, so you are just differentiating x square, right, with respect to x, so it is 2x only. Okay, now if I just say d of x square and just apply the integration sign, then integration is the reverse of differentiation. Yes or no? So you can just cancel out this thing. So you have x square here, right? Similarly, here also we have integration d of cot inverse x. So I could write here d cot inverse of 1 over x within the limits minus 1 to 1. All right. But can you see that this cot inverse of 1 over x is not defined at the point x equals to 0, right? 1 over x, right? When you put x equals to 0 at x equals to 0, we have 1 over 0, which is infinity, right? So this function is not defined at x equals to 0. Okay, so what should we do? We have to apply the first concept, this one, like we have to break the limits. Okay, but for that we should know the graph of cot inverse x for now. So let me just draw the graph here. It should be something like this. It should be within this point is not like that, uh, like this. Okay, so this point is your pi point and this point is 0, so it's always between 0 to pi, and this point is pi over 2. Okay, so can you see that when x equals to 0, we should write like this: cot inverse of 1 over x. So the limit should be breaking from -1 to 0 plus, right? Then plus cot inverse 1 over x, start from 0 plus to 1. See, I should write here not 0 plus, it should be 0 minus. All right. Okay. So when you solve it, what do you get? So you'll get cot inverse of, when you put the upper limit here, so it will be minus infinity, then minus cot inverse of -1, right? Then plus this is cot inverse of 1, which is pi over 4, minus cot inverse of plus infinity, right? So what is cot inverse of minus infinity? So when you approach to negative, like minus infinity, so it will be going towards pi, right? So pi minus. Now what is cot inverse of -1? So we should remember that cot inverse of minus x is always equals to pi minus cot inverse of x for all x belongs to R, right? For all real numbers. So we can apply this thing here. So I should write here pi minus cot inverse of 1, all right, plus pi over 4 minus. Now what is cot inverse of infinity? Plus infinity. So whenever you approach to plus infinity here, the graph is touching to 0. So I can say the answer is 0 here. Okay, so when you solve it, so you get pi minus, now pi minus, what is cot inverse of 1? It is pi over 4 plus pi over 4. So what do you get? So you get pi over pi minus 3 pi by 4 plus pi over 4, which when you solve it, you'll get pi over 2. All right, so the integration value of this function is pi over. Now let's just take the second example where the definition of the function changes. All right, definition of the function changes. Example number 2. See, very basic example. So integration from 0 to 4 mod of x minus 3 dx. Okay, so first of all, let's just draw the graph of this mod of x minus 3. See, you can directly see that this function changes the value at x equals to 3, right? I'm just assuming you have some sort of idea about the graphs. See, basically when you have to draw y equals to mod x graph, so it is something like this, right? So but whenever you do the transition from, like when you draw y equals to mod of x minus 3, you just shift the graph to the 3 units in the right direction, right? Like in the positive x direction. So the graph should look like this now, like this. Okay, now this point should be 3. Okay, this is 0. So we have to go from 0 to, like x equals to 0 to x equals to 4. So what does it mean? This line is x equals to 0, right? And let me draw x equals to 4. So this is x equals to 4. So what does it mean? That we have to find the area, we have to find this shaded area, right? Because integration of a to b f of x dx is always represented the algebraic sum, right? Okay, now you can see that the when x lies between 0 to 3, can you see this equation is y equals to minus of x minus 3? Because when you put in any value from 0 to 3, 3 is always going to be 1, right? So when you put in any value from 0 to 3, 3 is always going to be 1, right? So any value from 0 to 3, the value inside this modulus is negative, right? Value inside this modulus is negative. Let's suppose you put x equals to 1 here, so 1 minus 3 mod, which is mod of minus 2, so this value is negative, right? So when you do the modulus of negative number, you have to multiply with negative sign, right? So that's how from 0 to 3 this function looks like minus of x minus 3. Now after x equals to 3, the equation will be positive of x plus x minus 3, right? Because whenever after 3 you just put in any number, this value inside modulus will be positive. Okay, so now what is the value of this integration is, you have to break in the limits again, because from 0 to 3 function is different. So I should write here minus of x minus 3 dx, then plus, starting from 3 to 4, x plus x minus 3 dx, right? So that's now this is a simple integration. So when you solve it, so what do you get? So minus of x minus 3 dx from 0 to 3, then plus integration 3 to 4 x minus 3 dx, and this will be equals to x square over 2 minus 3x, negative here minus 3 plus, now this is again x square over 2 minus 3x, 3 to 4, right? So when you put in the limits, so what do you get? 3 3 is a 9 over 2 minus 3 3 is a 9, then when you put in 0, so it will be 0, okay, plus, so 4 square is 16 over 2 minus 4 3 is a 12, and then when you put 3, so it will be 3 is a 9 over 2 plus sorry, minus 3 is a 9, right? So when you solve it, what do you get? So minus 9 over 2 plus 9, then here we have 16 over 2 minus 12, then minus 9 over 2, then plus 9, right? So we can say this is minus 9 over 2, this is minus 9 over 2, so when you add them you'll get minus 9, and this is plus 9 and 9, which is 18, and then we have this we can cancel this thing at 8, so 8 minus 12 is minus 4, right? So 18 minus 9 is 9, 9 minus 4 is 5. So that's how you'll get the answer of the integration as 5. There is one more method to solve this answer. If you don't want to go with the integration, we can see this is a triangle 1, right? This is a triangle 2. So we know the area of a triangle. So when you find it, to let's suppose a1 is half into, what is the base? Base is 0 to 3, that means the distance is 3, and the height is, this distance is 1, not 1, this is 3. When you put in x equals to 0, when you put in x equals to 0 here, so 0 minus 3 mod, which is minus 3, which is 3, right? So this point is 3, so the height is 3 for triangle 1. Then we have area 2, which is half into base. Now base is 3 to 4, that means the distance is 1 unit times height. Now height is again this point, this is 3, so 3, so this is 9 over 2, and this is 3 over 2. So what is the total area? A1 plus A2, so that means 9 over 2 plus 3 over 2, right? Not 3 over 2, I think I did some mistake. It should be yeah, oh sorry, here see, you can see that this is not 3 actually. When you substitute x equals to 4, when you substitute x equals to 4 in mod of x minus 3, so 4 minus 3 is equals to 1, right? So this point is not this point is 1, so this distance is 1, okay? So the answer here is half into base into height, height is 1, right? So this is half, right? So here we have also half, so that means 10 over 2, which is 5. So in both the cases we got the same answer. You can see 5 is here and 5 is here. So if you know the graph, you can go by the graph and just do the easy method like this, And if you don't know the graph, then you can just change the change the value of the function where it at zero point 0.3, right? So in that way you can solve the questions of definite integration. There are many properties of definite integration, but for now we just stop here. Okay, thank you.